my screen. Tell me, you guys, are you able to see my screen?
Yes.
Yeah, it's Mathematics N2 exam paper. I hope all of you are able to follow up. Now, just as a quick recap of where we are, and so this is the part that we are looking at here. So yesterday we looked at that was day one. We looked at the part of LCM, HCF, and factorization, as well as fractions. So this is yesterday, but today I want us to cover this part. So this is day two. So for our day three, we're going to look at graphs, and we're going to look at goniometry, and which is the radians, the circumferential velocity, and the sectors here. Then day four, we will finalize with trig and mensuration. Then day five will just be dedicated to questions and answers there. So let's look into that. I think there is one thing that I wanted to just recap on some of you guys yesterday. It was actually this question when we were factorizing, to say just take note. I don't know how I was working around this one, but just let me quickly recap again there. When we're talking about given such questions, you need to be sensitive. I'm just going to do this before we go to the lesson. So we said you must arrange this. When they give you a question like this, they say factorize. Remember, the most important thing is it is mixed up. You need to put it in the form of ax squared plus bx plus c. So this is the standard form. So you can see that it's minus 2x squared with the squared there. All right. And then the 7 is positive. So you've got plus 7x. And then the 4 is negative, minus 4. And if you have to factorize this, let me avoid dealing with brackets, but let's just take it as is, whereby I say take this and that. That's your product. Multiply it. That's your p. So if you multiply minus 2 times minus 4, you get a positive 8x squared. Right? And then the center number, we called it the sum. So that's your sum. Sum means addition. So it is plus what? That is where you are getting your plus 7x. And then I say to you, then you look for the factors, but the factors, they are the factors of the product. Meaning, you are looking for here the two numbers that you need to multiply here, and to get 8 is 1 times 8, and then it's 2 times 4, right? And then when you have done that part, so the next thing now you are saying here, because it's what? It's negative 2 times negative 4, we are getting a positive 8. And then the next one is 7x, which is the sum. So if you look at these factors here, if I say I put a negative here, right, and then I say in this negative, when I add minus 1 plus 8, I say if I add that, I'll get a positive 7. If I take a calculator then say minus 1 plus 8, it will give me a positive 7. So when I write it, it will be minus 2x squared, right? So where there is 7x, I can write minus 1x plus 8x. See that? So this is what? If you look at this, this is my 7x. All right. And then after that, I've got minus 4. Then you look at factorization by grouping, as I said. You take your first 2 and you look at your last 2. So your first 2 here, what is common there? It's you can take out a negative is common, and negative x, right? And then if you take out a negative x there, you will have 2x plus 1, right? And then you look at the second one, 4 is common, and then you have 2x there. Actually it's 2x minus, am I right, minus 1 there. Again, I think I don't know why this, I keep on stumbling on this. I think I didn't check it well. Again, it was supposed to match that. I'm supposed to get 2x plus 1, 2x plus 1. I don't know why I didn't check again this question. I thought maybe it was me who was making an error. So again, apologies guys. But what you needed is to get 2x plus 1, to get another 2x plus 1. But I think there are some of them, well, which you can factorize except by quadratic equation. So I think I need to literally change the way this question was structured I checked on the question paper, it was like that. So I don't know why then I think it was an error question that I must admit myself. I thought it was me who was making an error. So, but anyway, let's look at today's work. We are looking at, we did that, we're here, exponents. Now, very important section, but more importantly are the logarithms. So I'm not going to go through these rules and laws and everything, but I'm going to apply them and be reverting back to you whenever we're looking at these exponents. All right, so let's look at some practical questions which can make us then use these rules and these laws. So it says here, simplify the following exponent without a calculator, you see, and you are given that. And guys, the moment they say without a calculator, I always say just take it and see what is the answer. So if I can use this, for example, I've got that bracket and I've got the inner bracket and I've got 1/3, just to check what is my answer here, and then close the bracket to the power of 2, and then close the bracket to the power of -3. See that? So I'm getting what? I'm getting 729. Now the question is, can I prove how they got that? So let's look into that. How did the calculator get 729? That's what we are saying. So first things first, try to simplify the inside. So here, look at that. If I'm given 1/3, remember what is 1/3? 1/3 is same as 3 to the power of -1. If you do that, you get 1/3. So meaning I can use this law which says 1/a to the power of m. This is what? Take it to the top, it becomes a to the power -m. So this rule is the one that says, if I say to you, what is 1/3? Then you're going to say it's 3 to the power of -1. So if I take that 1/3 there, and then close the bracket and put that 2, and close the big bracket and put the -3, it becomes now better, whereby the 1, now where are we now? We are using this rule here. We're using this rule now, this one, which says if m and n, as you can see, a to the exponent m to the exponent n, you must, when that like that, you multiply. So that's what I'm going to use here, whereby I will say big bracket, it's 3 to the power -1 times 2, close the bracket, -3, which is equal to 1 times -2, -1 times 2 is 3 to the power of -2, again, close the bracket, -3, which is same again, where you multiply those exponents, is now 3 to the power -2 times -3, which is 3 to the power of 6, and if you check 3 to the power of 6, it will give you that. So those are things that they need to see as you're working. You're using the rules or the laws to go about that, so that you can tell that I never used the calculator. Similarly, on this one, it was the same approach here, and then you take that and say 3 to the power -1, put that, you've got now -3, then you put that, you've got -2. So you start with the inside. Please don't start outside, better to start inside. It can still give you the same answer, but always go inside out. So -1 times, to show the working, -1 times -3, and then you close the bracket for -2, which is equal to, now negative, it will be positive, 3 to the power of 3, and then you've got the last one, which is -2. And then if you continue that, you will get now 3 to the power of 3 times -2. They need to see that working, which is now 3 to the power of -6. Okay, so they say don't use a calculator, so you leave it like that. That is that. But if you check with the calculator, you find what is 3 to the power -6, it will give you 1/729, I think, which is, you can test again your calculator that, and if you do that, you can just see whether it matches the answer there. Alright, so that is that, guys, just to begin our lesson, just using the basic laws there. Now another question I brought in was this one, simplify. It looks simpler. They brought it, I think it is 2 exams back, that is July or so. They say to simplify that. So now, first things first, remember when you're given, of course there are a little bit of logs now. If I give you ln e and x here, we're going to cover it in logs. This x, you drop it down there, then you've got x ln e. But don't forget the base for e, we're going to cover it later. There is a base there. So ln e is equal to 1. So here you've got x times 1, and the answer here is x. So which means ln e to the power of x, to the ln e to the power of ln, okay, there's e there, e to the power of ln e x is same as saying e, this became x, so it's e to the power of x, because that is simple x when you just solve it like that. Are you seeing that? So just be careful when you're solving it to say, if I give you, first solve that part, and that part is what I was doing here. It gives you x, then when this becomes x, then the answer is e to the power of x. If I did move a bit faster with it, just remind me, because this is mainly under logarithms, but I bought it because it was also showing some exponents. Look at this one now. Simplify the following exponents without a calculator. Again, you are given this part. You just need to be careful here not to mix up things. For example, you have got 2 signs here. For the one, there is a hidden 2. If you see that, it means there is a 2 there. It's square root. The other one is a cube root. So what you need to do first, let's deal with the outside. You open your bracket. When it's by the way, if I give you and say to you, I give you that sign, it means bracket to the power half. If I give you 3 as a cube root, it means bracket to the power 1 over 3. If I put nth root, it means bracket to the power 1 over n. Don't forget that. So which means if there is a 2 there, there is a power half on the outside, and then again there is an inside one here, but it's cube root, which is to the power 1 over 3. See that? And then that's where now you find the 64, P30 and Q36. Just be careful like that. You see what I did? This is inside. Let me just erase this. So you've got this one, which is also inside that one. Right, and then all over 2p negative 2 q to the power negative 5. That's what you're having. So now from here, it's a part of now being able. So they wanted to test whether are you able to understand what these mean. So those ones, the half is outside, the cube root is inside. But as I said, start from inside out, meaning multiply this 1 over 3. But now this 1 over 3, let me undo this. First convert this 64 here. I think that's a better plan. This 64, change it. I told you with the calculator what you do. You take a calculator, you say what? Let me just take a calculator so that you can work together. You take a calculator, you say 64 is equal to, you say shift, then your button is effect here. And I think it will give you 2 to the exponent, what? 2 to the exponent 6, I think. That is 64. So you must write here as 2 to the exponent 6. It helps you because at the end of the day now, everything is in exponent form. From here, start with the what? 1 over 3, please. Inside out. So the 1 over 3 is multiplying. So it will be each item there. 2 to the power of 6 times 1 over 3 as exponents. And then p to the power of 30. Don't forget, it's times 1 over 3. Everything exponents. Q to the power of 36 times 1 over 3. See that? Don't forget, you're not done. This, there is still a half outside. Then all over 2p p negative 2 q negative 5. See that? It's not really much, but you still continue multiply that. What it will give there, it will be that 6 gives us a 2 there. The 30 will give you 1 over 3, I think it's 10. Here it will give you 1 and 2. So what we have now, we've got 2 to the exponent 2 there, and then you've got p to the exponent 10, you've got q to the exponent 12, but this is still multiplied by 1 over 2 and then divided by 2p to the power of negative 2 q to the power of negative 5. So there is not only one way, I'm just showing you something that you can follow up and avoid some errors. Then this one again, it multiplies everything inside. So you've got 2 to the power of 2 times 1 over 2, p to the power of 10 times 1 over 2, q to the power of 12 times 1 over 2, you see, as exponents, over 2p to the power of negative 2, q to the power of negative 5. See, so this continues further. Now you are multiplying that, it will give you 2 to the power of 1. 2 into 10 gives us 5. It's p to the power of 5. Q there, it gives us 6. It's q to the power of 6. Now look at this, over 2p to the power of negative 2, q to the power of negative 5. Now what we do from here, you apply the rules again, the laws of exponents. So it was not possible for me to apply to deal with the bottom here as long as there was a bracket here. So first I must deal with the brackets on top. Remember, both must say brackets first. So that's why I was dealing with that bracket. So from here, you are forced now to say, okay, this can cancel out. And then look at q. So I mean p, you've got p to the power of 5. Now if this p here goes to the top, if this one goes to the top, tell me what happens. It was negative 2, so it will become what? Positive 2. And then same thing, I've got q to the power of 6. If this q here goes up, it was negative 5, it becomes positive 5. Those are things that you must remember. Meaning 1 over a to the power negative m. Now you just interchange, it becomes a to the power of m. If it was 1 over a to the power positive m, it becomes a to the power negative m. Look at how the signs are interchanging. Hence the final answer then becomes equal to p to the power of 7, q to the power of 11. Alright, you might have check your errors. As I said, always remember, you choose any values of p and q, then you can always test your answers. But it's too big, I'll show you one that becomes simpler to test. Alright, then you can test that. Look at this one again. Similarly, these are questions that I got from your previous papers, guys, and each one is 3 marks. So look at this one here. They say you must simplify that. It looks also simpler, but you just need to be careful here. First of all, you must ask yourself, this negative 2, what must you do to it? It goes inside. Now if it's AB, it means the power is 1 and 1. Then outside is that negative 2. Then over AB, and then again it's 1 and 1, and then overall it's negative 1 over 3. So you start with the inner one here. It goes in each of them. So what you have is a to the power 1 times minus 2. So it simply becomes minus 2. B negative 2 over a b. But look at this. You still have this negative 1 over 3. Now be careful now. This negative 1 over 3 is affecting everything. Look at how it extends. It's not only affecting the top but also the bottom. Meaning you are forced to take the a first up and the b up. Unlike in the previous one. In the previous one, we were forced to deal with the top. You see, until everything was done. But here, you can see that this is extending to the bottom. So when it does that, the a, there is a 1 there and a 1 there, it will interchange the signs. So you've got a to the power negative 2 The positive 1 will become negative 1. b to the power negative 2, this positive 1 will become negative 1. See that? Then bracket, we're not done with that, negative 1 over 3. So hence, negative 1, negative 2, you get a to the power negative 3 there, b to the power negative 3 there, bracket, negative 1 over 3. See? Then you can now apply that exponent now. It can come in on each of them. So it becomes what? It becomes a to the power negative 3 times negative 1 over 3. See that? And this b negative 3 times negative 1 over 3. That's what you're having. Equal to, then you can multiply that. It becomes a to the power negative negative is positive 1. And this b, again, negative negative is positive 1. So you've got a, b as your answer. I think this one is much smaller. I can test it here. For example, for testing, you say let a, I use simple numbers, be equal to 2, and let b be equal to 3. Just I know a, since the alphabetical order a, b, it's 2 and 3. So what I do is I take my values. Remember, a is 2 times b is 3. What is 2 times 3? It must be 6. So let me go to my original here. When I put my a and b, the final answer must give me what? A 6. So let's do that with the calculator here. So what I do, I've got a fraction, a bracket. Then from a bracket, I've got a fraction. And then on top, I've got, am I right? Yeah, I've got that again. So a is 2 times 3. I close that to the power negative 2. I hope I did that right. And then go down. And then a, which is 2 times 3. See, I'm testing that. Then close it to the power of negative what? 1 over 3. So I say equal to, you see, I'm getting a 6. So when you see your answers matching that, that's what I was mentioning here on P and Q. When the answers are matching like that, you kind of get an assurance to say, okay, I think I did it right. Which means this guy here will simplify to AB. So those are things that you can just use to quickly test your answers. All right. So that is that, guys. It's still on exponents. I will want you to be careful of this one. If they give you such a question, say simplify the following exponents without a calculator. Just be a little bit careful here, whereby it's not complicated, just you need to know the strategy. Now, I want to compare these two. I want you to see how I'm going to work them out. Let me start by this one, because the one on the right hand side, because it's much easier, so that you can see how you deal with the other one. They want me to simplify. So what you do is you are given that 5, which is still the same, 2x minus 1 times, but you know 9 is 3 squared, guys. Remember that. And then you must convert 15. You say 15 equal to shift effect. It will give you 3 times 5. So 3 times 5 is what? Is 15. But your calculator will give you as prime numbers. So now when you know this, you come here where there is 9. This is how you can write it. It's 9 as 3 squared here. Alright. But now you can do it like this. And then you've got x minus 2. This is fine, but rather I prefer you to write it the other way around, whereby avoid the bigger bracket but put it the other way around and say x minus 2. Why are you doing that? Because you are helping yourself to remember that the 2 will enter there and enter there. You see that? Now I'll repeat again so that you can see what most students usually make an error. Look at 3 times 5. So you'll know that 15 is 3 times 5. Then you put a bracket there, right? And then you've got 2x minus 3. If you forget this bracket here, if you forget it out, now what it will look like, it will look like you have got what? 3 times 5, and 5 is the one having the exponent. At that moment, you have lost it, you see. So be careful. These brackets are very important so that you can see that they are affecting everything inside. Same thing with that 2 here on top. It is very important. If you put a bracket, like as I'm saying, you say 3 to the power of 2, and then you write it as x minus 2 like this, you will think only this one is multiplying. So you find students now saying 3 to the power of 2x minus 2, forgetting that it's 2x minus 4. That's where the error is. Then this becomes wrong. So just be careful there. Then when you continue this, what does it become? You have to now, as I said, open that bracket on top. Then you'll have 5 to the power of 2x minus 1 times 3 to the power of 2x. And then we say 2 times 2 there is negative 4 because it's negative all over. Now see, pay attention again. If that was a power 1, it's 3 to the power of 2x minus 3. You see, it's on 3 times again 5 to the power of 2x minus 3. That's what I want you to be careful of. Most students will have sometimes made an error with the 3. When it's like this, it's good to go. You use the normal laws of exponents, meaning, again, be careful now. When you are dealing with 5, you see, this 5 and that one, we are going to take this to the top. Again, when you are dealing with 3, the 3 here, we are going to take the 3 to join the top. But now, look what I'm going to do. With the 5, it will be 5 to the power of 2x minus 1. This is fine. But when it's going to the top, this exponent must interchange signs. Now, what is the sign for 2x? Is positive. So it will become negative 2x. Because it was at the bottom going to the top. Why? 1 over a to the power of m is a to the power of negative m. Positive m become negative m. If it was 1 over a to the power of negative m, it is equal to a to the power of positive m. You interchange, guys. So same thing, 2x was positive, now it's negative. 3 is negative, now it's going to be positive 3. Seeing that? Times, you do the same with 3. 3, the one on top is maintained as is, 2x minus 4. Now 2x here at the bottom, positive, become negative 2x. Again 3 become positive 3. So that is the main thing that you just need to be careful of there. Then when you finalize your answer, it will be 5 there. 2x minus 2x gives you a 0. Minus 1 plus 3, it's squared. Then times 3, again 2x minus 2x, minus 4 plus 3 is negative 1. So if you check your answer with the calculator there, it will be, I know they say don't use a calculator, but if you say 5 squared times 3 to the power of negative 1, you will see it's 25 over 3. Why? Because 5 squared is 25. The 3 will go back down because it's negative. It will be over 3. I wanted to say 25 there. Alright, so guys, that is what you get as your answer, 25 over 3. Alright, you can test it again, as I said, simpler. Look for 25 over 3 here. Choose any value of x. Maybe say x is equal to what? Let's say 7. Just any number. Let's put, for where there is x, let's put 7. It must give us 25 over 3. So if I just grab my calculator here, when x is 7, so what you have, it's good, guys, to test. Always try to test your answer. So how do I punch that? Is this 2 as an exponent times 7 minus 1. I said let my x be 7. And then it's times 9 again to the exponent of 7 minus 2. And then at the bottom, play down, and then it's 15 to the exponent of 2 times 7 minus 3. It must give me 25 over 3. Did I do that right? Okay, let me check if I'm doing that right. There is 15 to the power, oh, there it is. I see the error there. It's 2 times. Let's do that. There it is, 25 over 3. So guys, this is what makes you kind of feel more, as I keep on saying, you are more assured of your answer. Now, that was the multiplication. Now, this is where I want you to pay attention. There was a multiplication sign here, so the laws are not a problem here. you just use the loss because it's multiplication. What about when it's like this and you have instead either a negative or a positive? Here the keyword there is factorization. We are going to factorize, don't forget that. But how do you come about factorization? This is how you're going to apply this law. Look at this. If you give me this rule, a to the power of m times a to the power of n, you remember the law? If the bases are the same, what do? It's m plus n. You add the exponents. So I want us to read this rule going backwards. Meaning, let me erase it so that it doesn't confuse you. If I say you are given a to the power of m plus n, you see you're going backwards now, equal to a to the power of m times a to the power of n. I didn't want to have both of them like that, but you can see that is the previous rule. We were reading it this direction, where it was same base, I add the exponents. Similarly, I just want to take this guy here and write it 5 to the power of 3n, 3n plus 1. What does it become? Using the same rule, it will be 5 to the power of 3n times, see where there is a plus, that's where you put a times, 5 to the power of 1. See, I broke it here where there is m, the plus times n. Same thing, 3 plus n, that's how it became. Now, we will apply to each and every item there. That's what I wanted to show you. So now, how does it become? This whole thing here will now become, using that same method, it will become 5 to the power of 3n times 5 to the power of 1 minus 5 to the power of 3n times 5 to the power of negative 1 now, divided by 5 to the power of 3n times 5 to the power of what? Of 1. Now, a common error that students will make, I just didn't put that. This is what students sometimes see as the shortcut. They will see that and that. They just cancel it out and the answer will become that. Guys, it can't be as simple as that. 3 marks or 4 marks, usually it's 4 marks or 5 marks. You can't just be cancelling to say I've got 5 3n there, it's common, and then that's that. You can't do that because that's a mathematical error on its own, So what then do you do? From here you factorize. That's the part I talked about, factorizing. You can see that this guy is common, 3n 5 to the exponent 3n is the common one. So if you take it out here as 5 to the exponent 3n, then you write what is inside. So in here this will remain, you write 5 to the power 1 minus this will remain 5 to the power negative 1 over, at the bottom you maintain as is, 3n times 5 to the power of 1. Why? That's why you're factorizing, so that this can now cancel out. That is the main reason of doing that. Are you with me? From here, what do? That's you're left now with numbers only. Remember, they will say don't use a calculator. Now 5 to the power negative 1 is same as saying 5 minus 1 over 5. You can use a calculator to verify that, divided by 5. Please don't be tempted again to cancel that. You cannot. So you continue with it and say over 1, but take a calculator, they won't find out. If you are using a calculator to find 5 minus 1 over 5, you can just play with the calculator. It can simply give you an answer to say what is that? Let me take a calculator, say 5 minus 1 over 5. Anyone can know this. You can say it's 24 over 5 there, over 5, and then again over 5. See that? And then you continue, use the calculator again just to continue that. It's difficult to pick up that this person was now using a calculator. You say here fraction 24 over 5, but I'll show you how you can use your own working here to get that. The answer is 24 over 25. So let's say it's 24 over 25. You see, I used the calculator here on its own, but the question is, what if I wanted to work it out myself? From here, you saw that common denominator is 5 over 5 into 5 is 5 times 5, it's 25, minus 5 into 5, 1, there is 1 there, over 5. We are now doing the normal addition. 25 minus 1 is 24 over 5. Now this line you say divided by 5. Well, back to that part. Is 5 over 1 is 24 over 5 times. Remember when I said when you change from division to times, you swap like that. So it becomes what? 1 over 5 now. 1 over 5 when you multiply. So 24 times 1 is 24. 5 times 5 is 25. This is what the calculator was just doing, but they will still mark you across like that. Okay, that is one way. You need to factorize. If you get this kind of a problem, you can factorize. Alternatively, let me give you another simple scenario. If I say to you 3 plus 6 over 3, you know, it's a simple answer. This is simple, 9 over 3, because 3 plus 6 is 9, and the answer is 3. But how did the calculator do it? I can go on and say that 3 affects that and that affects that. Meaning, I can say 3 over 3 plus 6 over 3. See that? Which is equal to, now 3 into 3 I get a 1, plus 3 into 6 I get a 2. So 1 plus 2 is equal to 3. So you see, I got two ways of solving it. Same thing, same concept on the other one. If I give you now this part, let me just erase and bring this guy here, which was 5 to the power of 3n plus 1 minus 5 to the power of 3n minus 1 over 5 to the power of 3n plus 1. Now it's up to you how you want to do it. This affects and that affects. So you're going to have it as 5 to the power of 3n plus 1 over 5 to the power of 3n plus 1. Same, minus 5 to the power of 3n minus 1 over 5 to the power of 3n plus 1. Then these will cancel out to give us a 1 minus. But the good part is, look, it's better now. The challenge was this negative. If we were multiplying, it was going to be loss. But because of the negative, you can't. Now, since we are now dividing, you can take this guy to the top. So it will become 5 to the power of 3n minus 1. Remember that interchanging? What are the signs? Positive will become what? Negative 3n. Positive will become negative 1. Are you seeing that? And then you can go on here and say 1 minus, now 3n minus 3n is gone, which is 5 to the power of what? Negative 1, which is 1 minus 5 to the power of negative 2. You see that? Now, then you need to know what is that. Take a calculator. It will give you what is 5 to the power negative 2. It will be 1 minus 1 over 25. See that? Then you know now when you are solving 1 minus 20, subtracting that, 1 is same as 25 over 25. Then the answer there, 25 over 25 minus this, it will give you 24 over 25. This is the another option you can focus on. Follow the factorization, you still get that. Follow this one of dividing, you still get that. It looks smaller and quicker, but you need to be careful there when you're taking it to the top. If you can't, please follow the factorization method. Okay, so you guys are going to tell me what you think when we do our discussion at a later stage, but let's continue. I'm going to do this one and then give you a short break so that we can just stretch a little bit and everything. These are the equations now, and the equations are also very, very important for you to know, especially when you're dealing with exponents. For example, this question here is 4 marks. See, you're supposed to solve this. It says solve for x, and then how do you go about that? And then if I give you 16 to the power of x plus 2 over 64 to the power of 2x plus 1 is equal to 256. Guys, I always say the examiners already have worked this thing out. They will never give you random numbers. All the numbers are there for a reason. You just need to use your calculator. So you take your calculator, you say 16 is equal to shift fact. I keep on saying that function. It's a very, very important function. So you take a calculator, you say 16 is equal to shift, then there on that line there is a FACT. You press it, it will give you for 16. I think if you are also following up on with me, it will give you 2 to the power of 4, right? And I told you to avoid an error, avoid this version and then you say x plus 2. Instead, do it the other way around, because your mind will pick it up. If you just do it like this and you say x plus 2, this is what your mind will do to you. It will multiply 4 and x and forget that 2. But if you do it like this, because you are aware sometimes, you know, under pressure of the exam, already take it and say x plus 2 like this. You see, you are trying to protect that 2 so that you, instead of saying 4x, it will be now that and that. You see, you are forced to open it like that. Same thing, what is 64? Let me just verify here with my calculator. What is 64? What is that?
2 to the power of 6.
Okay, 64 is 2 to the power of 6. Okay, so I've got 2 to the power of 6. I put a bracket. It's 2x plus 1. What about 256? What does it give you? 256 equal to shift fact. I think it will be 2 to the power of 8 or so.
Yeah, it's 2 to the power of 8.
It's 2 to the power of 8. So guys, there is always a reason why they're giving you these numbers. You see, everything is in terms of 2. Then next thing, you have to open up the brackets. So when you open up, it will be 2, 4 times x, you've got 4x. 4 times 2, you've got 8, all over. Back again, 2, 6 there, it becomes 12x. And then 6 times 1 is plus 6, equal to 2 to the power of 8. Guys, you needed to express. You cannot just do anything except expressing everything in the same base. Now from here, let me just divide my space here. Take everything to the top, and you know what to do, interchange the signs. So you have got what? 2 to the power of 4x plus 8, right? Now we are taking the other on top, positive 12x, negative 12x. Positive 6, negative 6, all right, is equal to 2 to the power of 8. Then when it's like this, there is a rule which says if I give you a to the power of m is equal to a to the power of n. If the bases are the same, then you can equate this. It means m is equal to n also. So here my bases are the same, then I can equate this guy here. It means this side is equal to that side, meaning I can come back here and say 4x, you can bring in like terms, minus 12x plus 8 minus 6 is equal to 8. Then you solve that. 4 minus 12 is negative 8x here, and then plus 2 is equal to 8. Then take that to the other side. You've got minus 8x, I'm doing that subtraction right, is equal to 2. I mean, this 2 become negative, so it's 8 minus 2, which is 6. Then divide by negative 8, divide by negative 8. Why am I dividing? Opposite of multiplication, there is division. Don't forget, don't divide by 8, divide by negative 8. Why? That negative must go, the 8 must also go. Don't just divide by 8, you will lose it. Then x, if you use a calculator there, it will become minus 3 over 4. Now, there is the interesting part with the equations. You definitely need to test your answer. Don't just leave it. So you take that x is equal to minus 3 over 4 in here to say x is negative 3 over 4. Every equation, you need to test it. If you don't test it, you guys will be sabotaging yourself, because why can't you test the answer and see if you're right? There is 16 to the power of, what do I have? It's negative 3 over 4. There's nothing to lose. I mean, I need to test, is this thing correct? And then it must give me the right hand side. 64, and then to the power of 2 times, it's negative what? 3 over 4. I didn't put a bracket there. and then 2 times is negative there, it's 3/4. You just have to test it, guys. I'm just doing it for you to see what I'm doing. Then you need to know your calculator. The equal to, then I'm getting 256. I mean, it automatically tells you there is no way I can get that thing wrong, because I just tested it and it worked, you know. So that is where you fight to say, I know I passed that paper. Whatever case, minimum, I got this marks. There is another 4 marks. We're gonna end with this one. Again, we're solving for x. No numbers are given without a reason. What is 32? This is 2 to the power of 5. You can confirm with me also, but I said what? Put a bracket like that, 2x plus 1. And I know some of the concept might be a little bit faster. Rewind this video, go again. I will load, definitely, I promise you, you will have these videos by the end of next week. Actually, by the end of, we're finishing on Sunday. By Tuesday, please request if you didn't get any link to say, please, can we have those videos again? Because I want you to go through them when you are now working on your own different problems, you know, just the concepts here that you're trying to get hold of. Now, times, if they are giving you numbers with fractions, take this 2 to the top. Remember, there is a 1 here positive, it becomes 2 to the power -1. All fractions, 1/a is simple a to the power -1. All fractions are always can be written as exponents. Right? Alright? So that is 2 to the power -1, but I said put a bracket like that, and we have got x minus 6. Again, equal to 16 is 2 to the power of 4, bracket -4. What are you doing? Everything can be expressed in terms of 2. The good part is I'm multiplying here. I can apply the law. Same base, add the exponents. So what are you having? It's 2 to the power of, first I must expand there, which is 10x plus what? Plus 5. But don't forget, I'm adding. So I'm gonna expand this, which is plus minus 1x. I know you're gonna say, but why are you saying plus minus 1x? I'm trying to say I'm adding here because it's a times. So this plus here, this plus is representing when I'm multiplying, but it doesn't have any influence there. You'll know that whatever case, this thing will remain as negative. You see? So because the positive doesn't have a power, so it will become minus 1x. You open again that bracket. -1 times -6 is positive 6, is equal to 2 to the exponent 4 times -4 is -16. Why do you want that? You always want to maintain same base, same base. If you didn't change, you change some, but you leave out that, you're gonna have a problem, because the rule that you are trying to get hold of is make a to the power of m equal to a to the power of n. Same base, equal the exponents. So here, as I said, you take these exponents as they are, you equate them. So left hand side equal to right hand side. Now if you have that 10x minus 1x, I can do that. It's 9x. I'm already solving it. 5 plus 6 is plus 11 is equal to, then there it's -16. Guys, it's as if this 2 goes and these things drop down. But avoid this thing. Some students like this, they cancel out. Say cancel and cancel. You don't cancel out. It's a rule. If the bases are the same, equate the exponents. So we understand when you just do this to say, where does 9x plus 11 equal to minus 16 came from? We understand the same base, meaning the exponents are also equal. Then take this to the other side. You have got 9x is equal to -16, -11. And then what does this thing become? 9x is equal to this and this. If you use a calculator, it's 7, it's 27, -27. But you can test with the calculator there. Divide by 9, divide by 9, and then x is equal to 9 into 27 is -3. You can verify that. But guess what? I don't need to hope and pray that it was okay. I come here and say, okay, if my x is equal to -3, let me test it and see that it balances. My left hand side must balance with my right hand side. That's all. So take a calculator and check it out. So if I do that, let's start with the left hand side. So I've got bracket 32, that's how we test it, and then it's to the exponent of 2 times -3 and then plus 1, right? And then again times, open bracket, it's a fraction, 1/2, and then close the bracket, to the exponent of what? X is -3 and -6 equal to, see, I'm getting a funny number here, which is 1/65536. Let's just keep it in mind, 1/65536. That is my what? That is my left hand side. Then I must check my right hand side. Already I'm given that number. I want to see if this 16 to the power -4 is this number. So I'll write fraction, I mean bracket, 16 to the power of -4. You see, there is that number again. So left hand side equal to the right hand side equals, I'm correct. So that is that part, guys. So what we do is, I just want us to take a short recess, and the good part is it allows us to come to the new concept of logs. So what I want us to do, guys, is just take a short break, just a minute to 9. Let's take a 5-minute break, and then we'll be back at 5 minutes after 9, so that you can just refresh. And I keep on saying, I know you guys are tired and you need to rest. Let's just get this done and out. Now, logs, also basics, is logarithms, but I will come back to this concept that I feel that's the main one that kind of is changing from N1 to N2, whereby you are given a base and you have to change the base. But we're going to look at a question that deals with that. So remember this rule, I'm going to come to it, and that's the part when you start dealing with logarithms that sometimes they becomes a bit challenging. But look at these questions here. These are logs now. Simplify the following logarithms without a calculator. Now you have to apply the rules of logs. Now what is the main rule in logarithms when you are adding? Let's start from this one here. You see, if it's log same base, let me just make it bigger. If the base is the same, a and a, you what? You multiply it, xy, meaning log base a of x plus, you see, if I'm adding, it's x times y. But if I'm subtracting, it's division. Those things are what you must remember. So if I come here and say, what is the sign here? It's subtraction. So it means equal to log 9/4. That's what it means when it's subtraction. Are you with me? And then again, over here, what do we have here? You have also log 81 minus 16. So what you are having there is, I don't know whether I'm doing this right, but it's fine. It's log 81/16. But this is taking me nowhere. It means actually the approach is not right, but that's still correct. It's a correct procedure where it's minus, you divide. Now, because of the way they've done it, they gave you special numbers. There's a reason why they gave you 9. So this is same as saying log, remember 9 is 3 squared. See, that's what they were getting at here. Minus, again you come back, log 4 is what? Is 2 squared. That's what they were getting at. Over, they gave you 81 here, log. Now what is 81? It's up to you how you want to do it, but 81 is 9 squared, but at the same time 81 is 3 to the power of what? Is it 3 to the power of 3? Not 3 to the power of 3, but 3 to the power of 4. Just check with the calculator, but you see that this is 81. Minus, again, what is 16? 16 is same as log 2 to the power of 4. So this is where they wanted to lead you to. Now, there is this rule of logarithms. Let me bring it to you. It says, if I give you and say log in base A, and then I say b to the power of m. See, b is the number. Now what they do is you take the m, you drop it I think we did when we're looking at the first part of logs. So the answer then becomes what? This is same as saying equal to m, because the m you have dropped it. Then you say log a of b. You see that? So you must always know that this m can move to the top. It becomes an exponent there, or it can go back there. So here, same way, these two can drop, this 2 can drop, this 4 can drop, and this 4 can drop. That's it. So let's do that. It will be 2 log 3 minus 2 log 2 all over 4 log 3. See where it was getting it now? Minus 4 log 2. So what they were getting at this, guys, is they wanted you then to see a pattern here. Look, log 3, log 2, log 3, log 2. But how do you cancel? Please don't be tempted. Don't be tempted to do this. It will be wrong. For you to do this, that's suicidal, guys. Don't do that. That's wrong. Mathematical error. That's not allowed. Why? Because there is a negative sign in here. You can't just cancel out. So you might get almost a correct answer, but still you'll be marked wrong. The procedure is wrong. So what do you do? Look at 2, factorize it out. That's where you take out 2 outside. Inside you'll be left with log 3 minus log 2. See that? And then you close the bracket. Then what's common? 4 and 4. Take out 4. See how it's going? Then it's log 3 minus log 2. See how this thing was? Then you are allowed now to say, I'm cancelling the whole bracket of log 3 minus log 2, log 3 minus log 2. Then they will allow that. It's mathematically correct. Then you are saying 2 into 4, it's 2. So the answer is 1 over 2. Understand? And of course, this is simpler. Take a calculator just to test it quickly. You take a calculator, it's easy. This one, you just say log 9. Now the calculator will open a bracket. Please close it first. Minus log, the moment you say log, an open bracket is 4 and close it. Otherwise you'll get things wrong. Log 81, close the bracket, minus log 16, close the bracket. And then there is the half that we're getting. So just remember such things. It's a question, it looked a bit funny. If I used the normal law, remember what I did? I said log 9 over 4, then I saw there's nothing common there. What am I going to do next? And then again 8 1 over 16, there was nothing common until you recognize what is 9, what is 4. All these are squares. You see, that is that part. Now there's another one. You are given that this one to say you need, what was the question? Simplify. How can you simplify this guy? It's easy, not easy. That's okay. This is not easy now. That is where I was telling you about changing the base. Now listen to this one. I want you to pay attention to this. If I give you log in base A of B, and I want us to change a base to any base we can think of. Maybe you want me to give you to base, let's say base 5. If it's base 5, how are you going to do it? You're going to say log, now B will remain on top over log A will remain at the bottom now. Then you just put the base 5 here and 5 there. Let me repeat again. It doesn't matter which base you want to change to. The base that you want to change, B, as you can see, goes to the top and this one goes to the bottom. It's in a fraction. So how do you write it? You write it as log, the B is on top, whatever base you want to put here, over log whatever base you want to put, and the A goes to the bottom. Now this question that they gave us here of this 64 blah 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 blah, they said we must simplify it. Now let's check with the calculator. What does it give us? This thing of log 64 of 8. See, it's giving me a half. Now the question is, how do I go about it? Remember, change the base. So that's A. So if A is equal to log base 64 of 8, now I need to change the base. How can I change the base? Usually when they give it like this, already you have got a base of 64, I want to make a base of 8. Just play around these numbers. So I want to go to change it to a base of 8. Is equal to log, remember 8 goes to the top, over log 64 goes here. But I want a base of what? I want a base of 8. I want a base of 8. See that? Why 8? Because already I've got the 8, so I want to play with the numbers that I'm already having. Now there is another rule which says if you are given log, you've got a and a. If they are the same base in the number, this becomes 1. So look at that, 8 and 8. That's 1. So equal to, you've got 1 over. Now 64, what is 64? 64, guys, is 8 squared. See? So then it's 1 over log base 8 of 8 squared equal to, back again, when you see the square, what does it do? It drops down. Then when it drops down, what do we have? It's 1 over, now the 2 is down, log base 8 of 8. We are back to that concept now. This becomes a 1, which is 1 over 2 times 1. Hence we got 1 over 2 as the answer. So that is how, in as much as it looked simpler like that, but you can see that it flows. This can just become 3 marks on its own. So I will encourage you, try practicing that. This is where you change the base. Alright. I think I got 2 of them. So I'll give you another one so that you can get more comfortable with it. Look at number 3. It says we must simplify this guy. Now look at the bases. The moment you get 2 types, base 2, base 4, you can't apply the rules. Please guys, you can only apply the rules when the base is the same. So when it's like that, it means you have to change the base. Now what do I do? From here, I'm given, for example, let's say I want to change everything to base 2. So which means I must deal with this guy here. So meaning if I've got log base 4 of 2, always change. Why am I changing to base 2? Because I've already got 2 there. So the 2 is on top. Then that over log base 2 of what? Of 4. See that? Then equal to, then 2 and 2 will become 1 over. Now what is this log base 2 of 4? It's simple what? Okay, let's leave it like that maybe. Or let's simplify it once. Remember 4 is 2 squared. So I'll get log base 2 of 2 squared. Let's take it further once. Now from here, you take this 2, you drop it. See, I'm just going it further so that I just write the answer. It's just 1 over 2 log base 2 of 2. So you agree now? This is 1. So the answer here is simple 1 over 2. Just this part. This is 1 over 2. But you can quickly test with your calculator. It will give that. Again, look, I was dealing with this log base 2 of 4 and it's also appearing here. Which means even here, I will still get what? A 1 over 2 scenario. So when I work it out, I'll be able now to say, let me take it down here, to say 5 log, because they need your working now, base 2, 4 is what? Is 2 squared, you see that? Plus, now what is your working? Then that's when you say log base 2 of 2 over log base 2 of 4. See, I'm following up this working now. Then from there, you know, you drop things. Just gonna shortcut some of it. Take this to the other side. Now look what it does. When it goes to the other side, it becomes a 2, remember. But now what does it do to this 5? It comes here and multiply. So you will have 5 times 2. Always remember that. It doesn't add, it doesn't subtract, but it multiplies. Then you will have log base 2 of 2. So this 2 here, I somehow forgot it on this side, because you see when I dropped it, I didn't forget it. It was down here, so it's there. I thought maybe I forgot this 2. So same thing here, plus 1 over, we did agree that this was what? you take this as log base what? Base 2 of 2 squared. Remember where I took this and dropped it. So now what do we have here? If you still remember, we said this becomes a 1, so it's 5 times 2, which is 10 times 1, plus, you remember what it did, this gave us 1 over 2. From the old one, we got 1 over 2. So the answer there it is. It's 10 plus 1 over 2, which is what? Which is 10,5, you know, which is 10 and a half, whatever case, 10,5 or whatever thing you have to do. But I think I'll be comfortable if I try to test this thing and see whether it gives me, you know, the answer. Let's try to quickly test this. So there is, now careful now, logarithms are very tricky. If you don't test them right, you'll get wrong answers. So that 5, I cannot my calculator just appeared. I cannot just put it as 5. You'll see like what I mean. If you just say this 5 log, you'll see what I mean when I'm talking about that it can behave on logs. If I say 5 log, not this log, 5 log 2, and then I put 4 there, see, then I say plus log and then 4 of 2. Let me see what it will give me. Equal to, you see, it gave me 21. I think this one actually is fine, 10,5, but sometimes it might give you an error because of this 5 here. So what I will encourage, if it gives funny, just try again, put a bracket there just to be safe. Put a bracket there to show that you are that 5 is multiplying everything. If you say equal to, you see it still maintains as 10,5. Usually I get sometimes wrong answers on testing logs, so I will say be very sensitive. If you are getting a wrong answer but you trust your method, please, on the calculator you might have actually been doing the wrong thing, because logs, sometimes the calculator can interpret what you are punching differently. Look at this one here. How many marks was this? 3 marks. It looks a bit long, but you just have to look at the trend. Why are they giving you the numbers? For example, take it one step at a time. Why did they give me this? Now look at this. If I say to you here, minus 2 log base 5. You remember now, what is 1 over 5? You know the laws of exponents. Take it to the top. It is 5 to the power of negative 1. Alright, and then you continue. I'm just going to continue with it. Now you know what to do with this negative. This negative must go this side so that you can have 5 and 5. So it will become what? Minus 2, but when it comes here, it multiplies. It becomes minus 1, or times minus 1, log 5 of base 5, which is equal to what? Negative 2 times negative 1, it's 2. That becomes 2 times 1. See, that guy is done. Plus, we are now on which one? This guy here. Why did they give me that? So you write again, 9 is 3 squared. So you've got 7 log base 3 of 3 squared. Right? Then again, take this 2, drop it, it will go and multiply. So what you're gonna have is plus here 7 times 2. See? And then to be log 3 of 3, and this thing becomes 1, so it plus what? 14 times 1. So it's not really complicated. You just have to look at the reasoning why they're doing what. This is a negative. Now let's deal with this guy here, which is minus, again, 125. Why 125? 125, guys, is same as what? 5 to the power of 3. So you'll have minus log base 5. They gave me a base 5 because that can be expressed as base 5. So it will be 5 to the power of what? Of 3. But I told you this multiplies with minus 3. Right. So when you're dropping this whole thing, which is 3 times minus 3 is negative 9, it will come here. So you'll have minus times minus 9. Be sensitive now. There is this negative and there is that negative. Right? Then you've got log 5 of 5. Then negative is positive 9. 5 and 5 times 1, or 9 bracket 1. So that is that. Then you just have to add everything here, which is equal to 2 plus 14 plus 9. And then I don't know what your calculator is giving you here, but if I try it on my side, 2 plus 14 is what? It's 16. 16 plus 9 is what? Is it 25? Yes, so this becomes 25. Let's try that. Now, obviously, I said be careful now with the calculator. Let me try it. If I get a wrong answer, I won't really struggle much, but I might make errors as I said. But look at this. Let's try to punch this. I prefer using bracket. So it will be negative 2, put a bracket, log 5, that and fraction 1 over 5. But now I opened my own bracket, I must close it because the calculator also opened its own bracket. You see? Plus 7, and then I open my own bracket, but the moment I say log, you see the calculator opens its own and close it. So I have got 9 here, then I must close my own. So I must close my own there. If you don't, you get wrong answers. Minus, there is what? There is log base. Okay, you see that power 3 there is very tricky, that negative 3. I prefer to drop it first so that it will be minus, drop it there. Okay, let me first not drop it and punch it as is. You'll see the difference maybe. What I mean, 125, delete the 125 to the exponent negative 3. That's where the calculator interprets things wrong. You see what it gives me? 431 over 27. But if I come here, remove this guy here, because this guy is the one who's causing all these errors. If I remove it and drop it down and bring it here, because it's minus bracket, if it drops it becomes minus 3. You see that? If I do that, don't know, but let me just delete that. Minus, the calculator will do its job. Minus 3 equal to, there is the 25, you see. But I hope you guys can just pick it up, but there is a sensitive side here. Minus 3. Why? Because this negative 3, I dropped it first. When you put a power, the calculator interprets it as a different thing. Or maybe if I try it this way, it's another thing I can try. Delete that minus, put a bracket here on this part of 125. Let me put it inside here, not outside, and say power of negative 3. Let's try that. Oh, okay, so that's what I was supposed to do. Put it inside instead, not on the outside. So those are different ways, as I say, if you play around with the calculator. Just be careful that you don't end up marking yourself wrong while you're doing the right thing. All right, so that is that. The next part of logs, that is very important. 4 marks, they will give you this question. Solve for x using the laws of logarithms. Then they want you to solve that. It's a very important concept, and guys, you need to know this way. What do you do here? When they give you this question, what you just simply do is introduce logs. Say solve for x, they give you that, so introduce logs. Sometimes if they say solve for x using natural logs, if they say the word natural, that's when you use ln. So you'll say ln x is equal to ln. But if they say logarithms, they don't specify. That's where you say here log x. The answer will be the same. Whether you use ln or logs, it will be the same. But if they say natural, you must go for ln. So is that is equal to log. See that? Then you write as is. Just put logs on left and right. So you put 3,89 times, put a bracket, 1,89. You put your squared as is. Then here you must automatically convert that so that you don't waste time. Cube root, I told you, put a bracket, it's 153 comma what, comma 8 to the power what, 1 over 3 as an exponent. That is the best way to do that. Then from there you just put logs. You see, I just put logs on the left and log on the right. Then you must apply the rules of logarithms. What are the rules saying? If you continue here with your log x is equal to, now log says when I multiply, I must add the logs. So you do this, log 3 comma 89. The times means plus. Log what? 1,89 to the power of 2. See, the division means minus. See, log what? 153, 8 to the power of what? Of 1/3. You see what I'm doing? This is the log that I'm using now. Just multiplication plus division sign minus. That's what you're supposed to do. Then from here you continue. You need to deal with this. 2 drops down, 1/3 drops down. Okay, so that I'm going to now work it a bit further now to say this will be equal to, I now take a calculator. I think I don't know whether it was Arno also who's also his mic is on. Please find me what is log 389 to give me up to maybe 3 decimal places. If you can work for me, log 3,89, so that I can just be writing the numbers here. Can someone just do that for me? Log,
Yes,
okay,
0,58
0,58. Give me up to 3 decimal places.
99.
Double 9. Let's maintain like that. Okay, let's give to 4. Continue. What is this log 1,89? Don't put the square, just log 1,89, because I've dropped the 2 already. Put a bracket.
It's 0,2765.
65. And then I will also say minus, I drop 1/3, don't forget, and then give me log 153,8.
It's 2,1870.
You see, that is that, guys. So you just do that, and then from here add for me everything here. Say 0,5899 plus 2 times that, 2 times 0,2765 minus 1,3 bracket 2,1890. I don't know whether it's visible enough. If you can do that for me. So don't forget, this is still log x. This is still log x. Alright, so you'll be now, don't forget the dropping means it's a mark. We are using the rule here. They will be marking you that part. So they'll be marking you this, they mark you that stage, you add here. You see, after adding, it's a mark.
0,413.
So 0,413. Now when you have done this, the final stage now, thanks man, thanks for that. The final step is, remember what is the base. Let me erase this so that I can write it nice. Now here you say log, there is a default 10 hidden here, x, so that's what you're having. So what you do now, how do you solve your answer? You say x is equal to 10, that base 10, this becomes an exponent, 0,413. Now can you find me 10 to the exponent 0,413? Then that becomes our answer. 10 to the power 0,413.
Yes, it's 2,588.
2,588. Now this then becomes your x. So what you do, of course, it's very wise to say, in as much as you know it's 2,588, I will take my calculator from here, and not just for the sake of everyone who's watching, and use it to find what is the answer here. It must give me also 2, it might not be the same because we're rounding off, but closer to the answer. Let's do that. I'll get that 3,89 times, put a bracket, 1,89 squared, right, over cube root, which is shift, I've got that, cube of 153,8. I hope I was doing this thing right there. There is 2,593. What was your answer, Anu? On your side, what is your answer? I don't know whether I was talking to Anu or someone else. What did you get?
2,588.
2,588. You see, now if you round off to 2 decimal places, remember how to round off, shift, setup, then 6 is my fix there to 2 decimal place. I'm getting 2,59, which also you'll think of, you'll get also that. Am I right? Yes. So you see that the answer is more or less the same. So that is how you approach this. Guys, I put a mark here to say, please don't go to the exam without knowing this. Sometimes they don't bring it, but if they bring it, it's just something that you will want to get it right. All right. And then next one, solve for x. Again, logarithms, not difficult. Mark allocation 3 marks. You're solving for x here using the logs. Now, don't forget log 1. Anything of log 1 is equal to 0. Doesn't matter whatever it is. So this thing is simply equal to 0. Log 1, you can test with the calculator. Just say log 1, you'll get 0. So what do you have? You have 3 log base 5 of x is equal to 12. Now this 3 is multiplying these guys. So since it's multiplying, you can divide by 3, divide by 3. That's what it means. Alright? So you divide by 3, you have got that gives you a 4. So you have got log base 5 of x is equal to what? Is equal to 4. Then from here, you use that same rule we did. This particular 5 will go up, it's a base, so it will be x is equal to 5 to the exponent 4. That's how it goes. Then that becomes the answer. You don't have to even go further, or you can get what is 5 to the power 4, you give your answer. I don't know whether it's, yeah, but it's a big number. I think it's 6 to 5 or whatever. But that's how you solve it. Alternatively, which might have been a bit longer, it's 3 log base 5 of x is equal to 12. I'll maintain 12 plus 0. Actually, it's very important to put the 0 there because they need to check, do you know that log b of 1 is 0? So this 0 can actually be a mark. Don't leave it out and say, I'm not going to show it. It's a mark on its own. Now, another thing to do, you can do this. Take this 3. Remember, this 3 can go back here. It's an exponent. So it will be log base 5 of x to the power of 3. Remember, that's where it came from. Is equal to 12. Right? And then from here, you follow the same rule. This 5 here, it will be x to the power of 3 is equal to 5 to the power of 12. I'm using the same rule here. In as much as it looks very, very, very big numbers, it's not a transmesh. Now, how do you get rid of that 3? What you do is you multiply by the inverse. 3, you multiply by 1 over 3. And then 5, 12, you multiply by 1 over 3. What you do on the left, you do on the right. There is gone. So you've got x is equal to 5. 12 times a third, it's 4, which is 5 to the power of 4. You choose which one you think best, but one way or the other, it will still give you the answer. All right. And then again, we just looking at a few of these logs here. It's also, they carry good marks. This is 3 marks. You're supposed to solve this guy here. Solve for x in the following. They gave you 1 over 2. Let me make it a bit larger. Look at this one. It's 1 over 2 log base 7. 1 over 49 is equal to x. So they'll never give you something that does not make sense. First of all, what is 49? It's 7 squared. So I can write 1 over 2 log of 7. Why am I getting it in terms of 7? Because my base is 7. So 1 over 7 squared is equal to x. See that? Then I take it to the top. So it will be 1 over 2 log base 7 of 7 to the power negative 2. Remember, positive to negative. Then from there, I make use of, if it's negative, I can drop it down. So what does it become again? 1 over 2. It multiplies as negative 2. Now look, I've got log base 7 of 7 is equal to x is equal to x. Why am I doing that? Because I want this thing to become 1. So it's 2 times this is negative 1. So it's actually here minus 1 times 1, which is equal to x. And x is equal to what? Negative 1. So you can actually try having this on the calculator. Don't forget to not make errors, put a bracket here. You put half log 7 1 over 49, it must just give you a negative 1. Alright, I'm not going to do it, just give you the benefit of a doubt on your side. Look at this one. Solve for a in the following. How many marks? 4 marks. It mustn't be complicated here. We are solving for a. Now what do you notice? Look at the power 2 there. But be careful now where to apply. You see, this is outside the logs. You see, so be careful here. Don't say I'm gonna drop it. And let me expand on this thing again. Don't be tempted to say I'm going to drop this 2 and drop it. See, when you drop it, it goes outside the log, so the law cannot apply. You can't apply the rule. You could have applied the rule if it was like this: log bracket a minus 1 to the power of 2. Then the rule was gonna apply. Be careful, guys. I can prove to you. If I give you this, say log base 4 to the power of 2 and log base 4, I do this to the power of 2. Let's use a calculator and see if we get the same answer. You see, let's start with the first one. Just use log 4, right? Now the squared, I put it inside, and then I because the calculator opened, I close that. Now if I say equal to, I'm getting what? 1,2. Now I'm going to do the other way around to see whether I'm getting 1,2. Put a bracket, and then I put log, and then I put 4, close, and then close and put squared. See, I'm getting 0,36. Two different answers at all. So be careful, be careful, be careful. They wanted to trick you there. So what you're supposed to do here is to say, okay, what is log 10? Guys, log 10 is 1. Why? Default base is 10, 10, 10 is 1. Because if you don't say anything, it means there is a hidden 10 there. That's what you must know. Now, after that, how do you then work it out? What you do, you have got this thing to say, that 2, you square root, opposite square root. It's like giving you this. If I say x squared is equal to 4, how do you solve 4? You square root both sides to get rid of the square. So that is what they were trying to trick you on there. You square root both sides so that you have got now log a minus 1 is equal to, remember we said log 10 is 1. Square root of 1 is simple 1. What is here? There is a hidden 10 there. Then you say 10 to the power of that, which is a minus 1 is 10 to the power of 1. Now take minus 1 to the other side. A is equal to 10 plus 1 and a is equal to 11. Let's try it. Let's put 11 there and see what it gives us. And then it must give us the answer on the right hand side. Or you can just, because of my time, just test it. Come here and put 11 here. Put a square. You must get log 10. But don't forget, what is log 10? Log 10 is equal to 1. So this whole thing must give you 1. Alright. So that was that. And okay, I'm looking, okay, my time allows a little bit. So look at this now. Equations, guys. It says solve for p in the following equation by factorization. I think I told you the importance of this guy. Factorize. If you can't factorize, then you're also going to be in trouble here. So how do you solve this? If you still remember, now since we're solving with they specified factorization, take that, multiply it, that's your product. So minus 3 times 2 is equal to negative 6p squared. Then the sum is the center. Sum is equal to p, but you must always know there is a 1 there. What are the factors? The factors of my product. These are the factors of 6, which is 1 times 6, 2 times 3. There are no any other numbers that I can multiply to give me 6. From there, when I add these numbers, guess what? When I add them, I must get a 1, which is positive. So how can I get a 1? I cannot add these two numbers and get a 1. But here, I can add numbers and get 1. If this is minus and this is plus, minus 2 plus 3, it is 1. So I can rewrite this thing as what? Minus 3p squared. See, where there is plus p, it will be minus 2p plus 3p. See where I'm going? Now plus 2. I keep on telling you that I never changed anything. This thing is my what? My p. So if you say minus 2 plus 3, you'll get 1p. So I didn't change anything, I just made it into 2 factors. Why am I doing that? So that I can factorize by grouping, take the first 2 and take the last 2. What is common in the first 2? It's minus what? Because you see a negative and a negative means it's common. Minus p. So minus p being outside, now 3 will remain and the p will remain here. Again, since I took out a negative, this will become positive now. Positive what? Positive 2p. Not positive, actually positive 2 only, because p is outside. Now you see 3p plus 2 is appearing again here as 3p plus 2. So what I took out, you take out a plus 1, because it's 1 doesn't change anything. So when I factorize that, is 3p plus 2, and then on the other side is minus p plus 1. This, remember, equal to 0. Now we have to solve for p. So either 3p plus 2 is equal to 0, or minus p plus 1 is equal to 0. That bracket is 0, that bracket is 0. So for p, take 2 to the other side. 3p is negative 2, positive to negative. Divide by 3, divide by 3, that's your p. So here, p is negative 2 over 3. On the other side, it's up to you what you want to do. You can take 1 to the other side, meaning minus p is equal to minus 1. Divide by negative, negative, meaning p is equal to 1. Or you could have taken p to the other side, but whatever case, there is the answer for p. Now, don't just get comfortable now. Remember, when you're solving for something, you have to prove it. So what you do is, you take the value, for example, minus 3 over 2. You come and test it here. Always test equations. So you say minus 3 bracket p squared is negative 2 over 3. See? And then it's what? It's squared. Remember? Plus what? Negative 2 over 3. That is my p that I got. And then plus 2. If you do that, it must give me a 0. Then you can test with 1 again. If you go back, where there was that, you put 1 now. Let me put 1 there. I do the same here. I just put 1 here. It must just give me what? It must give me another 0. You say those two answers, it means they are correct. So that is what you can do to solve that. There is another one. Solve for x by using quadratic formula. Another version. The first one said what? Factorize. But this one says strictly use the quadratic formula. Look at the way they gave it to you. They gave it to you to entice you. This is to trick you. Why? Because you are going to remember what is the quadratic formula. It says x is equal to minus b. You'll be given in the formulas, plus or minus square root of b squared minus 4ac, everything divided by 2a. This is the formula. Now your aim is to identify which one is my a, my b, and my c. This question, they gave it to you like this: x squared minus 4x is equal to 2. But you must know this one comes from a, x squared, plus bx plus c equal to 0. So you can see that this 2 is misplaced. It must go this side. So that you have got what? X squared minus 4x. From positive 2 is minus 2 equal to 0. Please, from here, if you can match this 2 here, if I can take it in and come and match it down here, you can see that what is my a. So a is not showing, there is a hidden one there. So you are able now to say, okay, for x squared, this is my a. For x, this is my b. And then for c, this is my c. See how I'm cutting? So a is equal to 1. B is equal to minus 4. C is equal to minus 2. That is what you're going to take in here to say now your x is equal to b. Look at the negative. There is always a negative for b, but there is a minus 4. Put a bracket and say minus 4. Here they are just checking your errors, guys. Square root of, when you do that, you will have bracket. Don't forget brackets. If you just write it like this, you say minus 4 squared. You have already lost it, because the calculator, if you say with the calculator, for example, let me check it to you. If I say bracket negative 4 squared, look what it gives me, positive 16. But if I just say negative 4 squared, negative 16. So be careful of brackets. So you need to put brackets there. And then minus 4a is what? Is 1. And what is c? Is minus 2. See, I'm putting everything in brackets. Then divided by 2, and then my a is 1. I'm not going to solve this. I will allow you, when you get time, you just solve it. But whatever answer, you get x as the first one for the plus. You get or x is equal to, you get the second one for the minus. So just, there are many examples you guys can just relate to when it comes to this one. Secondly, when you're solving this one, I'm just preparing it so that you can see how you could have solved it. Even this one here, quadratic formula, is not done the right way. You have an option of taking this minus 3 to this side to make it a x squared plus bx plus c equal to 0. It's an option. Or if you want, you can take these guys this side, both of them. If you do that, it will be minus 2x squared. It was positive. Now minus 3x remains as is because it's already on that side. Then negative 2 becomes plus 2 equal to 0. Then you can match now with this guy like this. It can give you your a. You can see what is my a, minus 2. You can see what is my b, minus 3. You can see what is my c, it's 2. Then use it in the quadratic formula, then you get it right. So that is that, guys. But if you're having challenges on this, I will use day 5 of question and answer. If you've got a question that you feel like on the quadratic formula I did not do justice, bring one and we can be able to work it out. Okay, it's just, I just want to cover a few concepts here that can be important for you. Simultaneous equations or simultaneous equations is another part that you must expect. But how do you solve this? It's also not difficult. You just need to follow up some few rules. Look at this. You're given this one. They say solve for v and w in the following simultaneous equations. So you write it 5v minus 2w. Now take 6 to the other side. Then say equal to positive 6. You do the same thing now. When you write the second one, write it matching the first one. So this is my equation 1. Since I started with v, I maintain that, minus 3v, and then 6w is positive, plus 6w. Take 30 to the other side, it becomes positive 30. See that? Then that becomes equation 2. That's what you needed to do there. From here, you can choose which one you want to eliminate. For example, let's say I want to get rid of w. So I multiply this equation by 3, multiply the equation by 1. Why? I want this. You'll see now when I multiply equation 1 by 3. Remember, everything is being multiplied by 3. So it becomes what? 3 times 5, it's 15v. 3 times negative 2 minus 6w equal to 3 times 6 is 18. Right? We continue. When we multiply by 1, nothing changes. Minus 3v plus 6w is equal to 30. That's the reason why I said we're eliminating w. Why? Look at this, 6w, 6w. So you're looking for two numbers that when you multiply them, they will match one of them, either v or w. If we didn't want v, we're going to multiply this one by 3 to get 15, this one by 5 to get 15. So it depends whatever you want to do. But when you multiply everything. From here, you rule it off. Then you ask yourself, must you add or subtract? If it's negative and positive, I need to add everything here. Why? Because minus 6 plus 6 is 0. Again, when I'm adding everything, it will be 15 plus minus 3 which is I think it will give me positive actually. It will give me 12v. I'm adding. This will give me a 0, guys. It's gone. Is equal to 18 plus 30. It gives me 48. See? Then 12v. How do I find v? Divide by 12. Divide by 12. Cancel out. Then I get my v is equal to 12 into 48. My v is equal to 4. There you get your v. Then from there, it's up to you what you want to do, but I'll always suggest go to the original equation. Choose one of the original equation, and that one is let me come here and write it here. The original says what? 5v minus 2w minus 6 equal to 0. But we know what is our v. V is 4 now. So you come here, say 5 times 4 minus 2w minus 6 equal to 0. Then you are looking for w. Take everything that side. Minus 2w is equal to 6 becomes positive 6. This is 5 times 4 is positive 20. Going that side is negative 20. Minus 2w is equal to, this becomes minus 14. Divide by negative 2. Divide by negative 2. When you cancel out, w is equal to 7. See this? There it is. Now, when you've got that, you know that v is 4, w is 7. So you come here and test your answer, obviously. So v is 4, w is equal to 7. Now, I think we're going to end it up here just after testing this, and then we're just going to have a quick talk. You guys, now, if I'm going to do this now and say, let's test it. You test it now on all these two. So remember, v is 4 and what? W is 7. So you say 5 bracket v, you put 4, right? Minus 2, w you put 7, and then minus 6. It must give me 0. So this one works. Let's try the second one. 6, my w is 7, minus 3, my v is 4, then minus 30. It must still give me 0. Then you know I got it right. So always test these things. Almost 50% of your paper you can actually test it, if not 60%. Alright, so guys, I will have to then end it up here on simultaneous equations. That's where tomorrow then it will start from the subject of the formula, and it wasn't much. That's where now we are going to be changing the subject of formula here. See this? And then it was almost the end, and then the word problems, as you can see here. Then okay, the word problems. Okay, someone is also indicating something. I'll just check now after my screen. And then also we will look at algebraic graphs and graph sketching and goniometry. That is what we're going to be doing tomorrow. And yeah guys, I just wanted to say that I don't know, any questions, you guys, maybe some comments and everything from what we have done so far. If you guys can just give me some feedback.
I have a question.
Yes, sir.
By the last question of the equations that we did.
Okay, let me just go quickly there. I think you were actually indicating this one. Okay, sir.
So I just want to know, will we lose any marks for shifting it to the left or the right?
No, it doesn't matter. It doesn't matter. For example, if you wanted to take it, for example, this one, you could have wanted to take it this side. Let me use a different one. Let's say you wanted everything this side, so nothing is remain. You have got 0 is equal to, now we have got 2x squared. Now the negative 3 become positive 3x, and then the negative 2 is already on that side. See, you can leave it like this, still perfect. So
okay.
Yeah, whatever case, your answer will match. You'll still get the same answers on that one.
Okay.
Yes. Alright guys, and then anyone also, just a bit of comments, and then any section that you feel like maybe was rushed up that you might want to bring on day 5, that you feel like it was a bit rushed up, comments, or any Just any comment, guys, before we wrap it up. Are you guys fine?
Yeah.
You guys are good.
You'll say you'll make the videos available by next week, Tuesday or sometime.
Yeah. Choose what I'm going to do. Actually, this is what I have already yesterday's video. So what I will do is a matter of me uploading it and then making it available as the day goes. But I want by Tuesday all the videos to be uploaded so that you guys can have access to them. Then I'm gonna give you the links to that.
Wow. Okay.
Yes, so that it can just assist you in revision and everything.